So here I have a Toshiba SA-735 stereo receiver and amplifier, and I was excited to get it because it's much like one I had as a kid and I still have today. I had the one that was the 725, which used a big amplifier chip, where this one uses discrete electronics. And so I bought it with one of the channels out, but it really looks like it's in nice condition. So I'm just going to take a look at it and see if I can figure out why that one channel is out. Yeah, the woodwork doesn't look like the highest quality. We just got our corners stapled in here. So here we have our power supply section, our rectifier, a couple of fuses, that's nice. And then our power section is right next to it. And we see our receiver. So it looks like it's kind of dirty, but it looks like it'll be easy to work on. So I'm going to give it a little cleaning first. So there's the amplifier section. It uses discrete components, that's nice. Kind of a nice big transformer too. So I don't have it hooked up to anything. I've got it plugged in through a dim bulb tester, and so I'm going to turn it on and see what happens. That look good? First I'm going to check to see if there's any DC voltage across the speaker terminals. Next to nothing. That's good. Okay, so I've got my scope hooked up across the left speaker leads, and I've got a dubbing load back there. Got my signal generator set up to 440 Hertz, amplitude 400 millivolts. Then I've got my scope set up, and so we'll see what's coming out of this channel. Here, got power on. Turning up the volume. The power's on. Let's see. Balance. Speakers A. Yeah, everything looks good. I'm not getting anything out of that channel. Well, it sure doesn't seem like the left channel is working. So I'm going to go over to the right channel. See if we can get anything there. Okay, so we're hooked up to our right channel. I'm going to flip it on. We do have something coming out. That channel seems to be working pretty well. It looks like there's been some interesting work in here. I don't know what's going on there. Looks like this might be a later addition as well. So I'm just checking the fuses here, and that one's good. That one's not. Well, that's good news, bad news. Well, I found a little piece of paper on the bottom. So it's a 250 volt, 3.15 amps. So I found a little problem. I've got this schematic here, and it's showing 41 volts and 41 volts across the rectifier. But then this copy, which is from the same document, or from the same manual, this official service manual, has 33.7 and minus 33.7, which seems closer for the output of this amplifier. So so if I look here, I got minus 34. I guess minus 33. And then, so 33.5 and 33.5. Man, it's dead on. That's good news. So I just have to make sure I use this document. Right, so that's 33. That's minus 33. That's 0.53 minus 0.6. And for this one, minus 33, 33.6, 0.5. Looks good. Well, certainly looks like everything looks good. So, okay, so I have the stereo on. I've got no input, and I still don't have the fuse in. And so I'm just going to check that we don't have some voltage on. Nothing. And next to nothing. So I'm going to put the fuse in and just see what we get. Okay, so I finished recapping just about everything except the phono amp, these power supply elements, and this little power supply over here. And I'll finish those up. I've got to pull this board out. Most of the recapping I was able to do just by accessing the back, and I've really been amazed by how good the sound is after the recap. So I'm doing a sweep here from 20 to 20,000 hertz, and you can see that there's very little variation in the output, which is nice. Before the recap, I was seeing all kinds of variation where the low end was very high and then it would drop off right away. So that's a good sign. So an issue I'm seeing right now is that even though I'm locked into a stereo station and it's sounding really nice on that station, and I'm just in my basement and I'm picking it up pretty well, I don't see the tuning of the signal meter moving at all. So I'm going to see what it takes to fix that. So the chip that's doing a lot of the stereo work is this. It's an LA-1231. I couldn't find a data sheet on that in English, and the 1235 seems to have the same model circuit that's actually being used in the stereo. So I'm using this data sheet as my spec. And if I look at the data sheet, there's an offset voltage coming out of pin 7 through 10, and there's a signal meter driving output of pin 13, and that's going from 2.2 to 5 volts, or 1.3 to 5 volts. Anyways, the offset voltage goes from minus 0.8 to plus 0.8, and so we're going to take a look at those voltages. So this is pin 13. Let's see. Then if I roll off the station, drops down. Then I'm coming nine, 10. So there's locked in. Then we're off the station. Then we're locked in. So it seems to be producing something. Then if we look at the centering, I think that's pin 7. And so that we're locked on a station now. Goes up when we go off station. It doesn't seem to drop down. I don't know. I'm going to have to take a look at that. I'm going to pull out the meter and see what's at the meter. So I finally got the signal meter to work. No problems with the circuit. The problem was the meter itself. So I cleaned it out with some parts cleaner, and then it still didn't work. I actually put it on my signal generator to kind of move it back and I put it on, you know, a tenth of a hertz, just to kind of work it back and forth. And I ended up having to back that screw out a little bit, and then it freed up. And let me turn on AM. Now it looks like it's nice and responsive. I still have to adjust it, but it does seem to be working nice and clean, so that's good news. So now I'm going to work on the other one, see if I can free it up. It's pretty pretty dicey operation, because I wouldn't want to damage any of that. So I'm just limbering the meter up because it was really sticking before. And so I just have my signal generator set to about 600 millivolts and half a hertz. And so you can see it running through there. I'm just going to keep cleaning it up and exercising it and seeing if I can get it that when I take the power off, that it just comes back into place. So here, see, it's not coming back into place, so we'll have to keep cleaning it and see if I have to adjust this little screw right here, which I did on the other one, and I just turned it 10 degrees or something, and that really loosened it up. Okay, so I carefully loosened this screw right here, and now it looks like it's let me try taking the center's perfect too. Perfect. So I'm going to just put a little bit of Loctite on there and then I'm done. So I've still got these caps to replace here and here and here, but I can't really get to them until I pull this board, and so I've got this here. I'm going to try to just tape up all these strings and remove the screws if I can, and then pull this board, finish the recap, and then I've got here are the lights, circuit boards for the lights, and I'm going to replace those with LEDs, and I'll try to put a rectifier on them too so the lights don't blink. So that's what I'm going to do. So I think we've got enough room here to do the work I need to do to get these out. We'll see about over here. Put some deoxit in our Okay, so I've got the power switch out, and I was kind of noticing that my power was kind of dropping out a little bit, and I remember when I had a stereo like this as a kid that this switch corroded very easily, and I've read other things about that. So I'm just gonna take these nuts out here and take a look at that switch and see if I can clean it up. Yep, it looks pretty dirty, so I'm going to clean up those contacts. I bet that's going to make a world of difference on that switch. So the bulbs that are in there right now kind of look like this, and I think there's just 1 out of 4 that is actually working. So what I'm going to do is I'm going to put LEDs in. I'll drill holes in here, put LEDs in, right? So there's AC power coming to here, so I want to convert it to DC because LEDs will flash at 60 Hertz, and it's kind of detectable. I don't like it, and so I'm going to change this to DC, and then I'm also going to put a resistor in there to limit the current. So I think what I'm going to do is just take this bridge rectifier, put it right here, have my AC power coming into here. There's another board here. I'll just connect that through there, and so both sides will get DC power, and that should get rid of the flashing. So this is the way the bulbs are currently wired. They just come right off the transformer, AC, just pass a fuse, and then they're just wired in parallel. So here's a circuit I'm going to use. I'm using a bridge rectifier because I don't like the blinking of LEDs if you don't use a bridge rectifier, and then I'm running through a 510 ohm resistor into 3 LEDs, and I figured out this resistance from the values of the LEDs, and then I just used an online calculator to figure that out. And so then we've got these circuit boards here that this is where the light bulbs were before. And so I just drilled some additional holes, and this is just a marker line here. And so I'm going to mount the LEDs here, and then cut the circuit traces, put in the resistors. So there we have our LED replacement. Like I said, it's running through the rectifier, and we got our negative rail and our positive rail, and then I just soldered in these surface mount. I cut the trace and soldered in these surface mount resistors, and then our plus and minus should come over to here where we'll solder in the next board, and we'll attach our power to here. We got some nice bright lights. So here's the final on the lights. Got them all connected together and soldered up. Nice and bright. And I picked LEDs that were in the same color range as the bulbs, so I think it's going to look pretty nice. Okay, so I'm just going to check out what we can do here. I've got a one kilohertz signal coming into our amp through the aux port, and then I have our oscilloscope set up, and I've got RMS voltage here, and I'm just running a signal through it. And so I'm just going to turn it up until it starts to distort, and that's and I'm just running it into a big 8 ohm resistor. It just starts to distort right in there. That's distorted, that's not. And so we've got about 18 volts RMS. So if I take 18 times 18 divided by 8 ohms, then I get 40.5 watts. That's looking pretty good. In fact, here I'm running it up to 19.5 and it still looks good. 19.5 times 19.5 divided by 8. That gives us 47 watts. That's really beyond the rating of this this stereo. So I think it's designed, it goes well beyond its design point. And if I feel the amp, it's warming up, but it's not terrible. My giant resistor though, that's starting to warm up. Well, I got the meters working. Here you can see and I'm just using a little FM broadcaster that's meant for use in a car, and it seems to work pretty good. And our alignment seems pretty good, so I'm not going to mess with it. And so I cleaned up the front, and it looks beautiful, and the sound is gorgeous. And this is coming in off the aux port. So I think the LED lights look pretty good. You can see them kind of broken out, but boy, the sound is great. So then that's it. I love the receiver. So I just love this receiver. It's got the knobs, have a beautiful feel to them. It's got a nice look to it, and the sound is amazing.